Welcome to grade 8 math. We are now looking at circles, and we already discovered in class all the different parts of the circle. And so let's just review them very quickly. So let me just get this circle into the frame here. So if we remember all the different parts of the circle, this is the center of the circle. Center of the circle is exactly the point where all of the points on the edge of the circle are the same distance from that center. Now there's different parts of the circle, so if I were to connect any line that passes through the center from one point of the circle to the other side of the circle, this is the diameter. So the diameter is the length. And so the definition of the diameter is any line or any chord that connects any 2 points of the circle that passes through the center. This is also the longest chord in the actual circle. A chord is any line that connects any 2 points on the straight line. That's a terrible drawing. But a straight line that connects any 2 points on the edge of the circle is called a chord. The kind of distance that is connecting the 2 points on the actual circle is called the arc. These two words are not often used to describe the circle, but it's always nice to know those words in case we ever use them in our discussions. Another part of the circle which might be interesting is the distance between the center and the outside of the circle. This is called the radius. So the radius is in essence half of the diameter. Since it's half the length, it only connects from the edge of the circle to the center of the circle. And if you notice, the radius is the same amount all the way around. So the radius at the top is the same as the radius at the bottom, is the same distance all the way around. That's what makes it a circle. So in class we looked at different objects and we measured their circumference by using a tape measure. We use the tape measure and we use the ruler to determine the circumference, which is the distance all the way around. It's the fancy word for the perimeter of the circle. And so we use the tape measure to measure that. We also use the tape measure to measure the diameter of the circle, and we will be comparing the ratios of the circumference and the diameter and the ratio of the circumference with the radius as well to see if there's any patterns that we see. If we noted this earlier on, different mathematicians such as the philosopher Archimedes and even from Egyptian, Babylonian, and Greek mathematics, they wanted to find this relationship too between the distance around something compared to the distance through something. And they kept finding that if they divided, whoops, I gave away the answer there. If I divided the circumference by the diameter, I always ended up with a number that's approximately 3.1 around that amount. So it's approximately 3.1, a little bit more, a little bit less. And regardless of the size of the circle, if I divided the distance around by the distance through, I kept getting this number 3.1, maybe 3 point something around there. Well, with more sophisticated technologies and with measuring devices, they continue to find that this actual ratio turns out to be this long number, 3.1415925, etc. And it continues on. There's no actual pattern. Because there's no pattern, we call it irrational because we cannot predict what the next number is in that case. But it continues on forever. So we have this irrational number, and instead of writing this number out all the time, mathematicians decided to label this number pi. So pi, the Greek symbol pi, or the Greek letter pi, represents this number, or this ratio, 3.14159. Or we could just say that it's approximately 3.14. For the purposes of our class and for the different number of digits on our calculators, we'll just use 3.14. So to determine the formula for the circumference of the circle using the radius, well, let's start with the diameter. We know that C over D equals this ratio pi. Well, if I move the D to the other side, just like in Magic Fence, if I divide on this side, if I move it over, it becomes multiplication. Now its circumference equals pi times the diameter, which makes sense because approximately 3 times the diameter is the length of the circumference. So this is our magic formula number 2 from our course for this chapter. Now, if we combine this with magic formula number 1, magic formula number 1 related diameter and radius. So we remember that diameter is equal to twice the radius, or 2r. Diameter is 2r. So if I combine this formula with my formula number 2, I now get the alternate formula number 2. So c is equal to pi times, instead of the diameter, it's 2 times the radius. Or I can rewrite this with the numbers in front. C equals 2 times pi times r, where pi is 3.14. So these are our magic formulas. So this was magic formula number 1 for this chapter, was this one. And now we are looking at magic formula number 2 and all of its possible other formulas as well. So we'll do some examples in class with circumference and with radius and with diameter and see if we can solve some problems as well. So hopefully you understood this lesson.